Good afternoon, everyone. My name is Anand Buddhdev, and I work for the DNSSEC in Amsterdam. And I'm here to talk about our experiences with DNSSEC. Apologies if it becomes very DNSSEC heavy this afternoon with Lutz and me, but please bear with me. I'd like to just start with a very quick overview of what the DNSSEC provides. I mean, the DNSSEC provides lots and lots of services. As you know, we allocate IP addresses, AS numbers. We have lots of community services. But there's a specific area that I work in is DNS services. And this is one of our services, operations of one of the 13 root name servers, KRoot. We have 18 different locations throughout the world. This is anycasted, IPv4 and IPv6. And we have 5 global locations. Global meaning that the prefix is advertised to all peers and propagated. And then the other 13 are what we call local instances, where the prefix is advertised with no export, meaning it's available only to the peers of that instance of the label. We usually tend to set up locations at internet exchanges so that we can reach as wide a community of users as possible. You might recognize this map. We have an instance at Espoo, at Finland Internet Exchange Physics. This is a local exchange, but a rather busy one. Sometimes gets up to several hundred queries a second. The other big DNS service that we operate is reverse DNS. So we get allocations of addresses from the IANA. So here's an example, 185/8. This was actually the last /8 that we received from the IANA. And we do delegations in this zone for our customers. So we operate 185.in/other.arpa. We run the service for this. And when we allocate address space to users and they need reverse delegation for their address space, we do that. So we operate all the reverse zones for all the address space that we receive from the IANA. For our reverse DNS, we have some infrastructure. We operate an Anycast cluster out of Amsterdam and London. And each cluster consists of 3 servers, and there are 2 sites, so 6 servers in total. And we announce our prefixes out of there. We are using a 32-bit ASN for this specific cluster. You can see on the seminar page that I am representing AS3333. That's just one of the AS numbers that we use. That's actually the DNSSEC infrastructure AS, but we have other service ASs, and this is one of them. On this cluster, we carry the inother.arpa zone itself. We also carry IP6.arpa. And then we carry all the DNSSEC's reverse zones on it as well as the DNSSEC's forward zones like write.net and so on. We also provide secondary DNS service for some CCTLDs, CCTLDs that are developing that need support. Here's an example for it, where we're providing secondary CCTLD for Syria. We're providing the service for around 80 CCTLDs, mostly in Africa, in the little island nation in the Pacific, stuff like that. We also run a few other DNS services. One of them is delegations for the enum zone. Is anyone here not familiar with enum? Don't be shy. Okay. So we do delegations for the enum zones. When a telco in a country wants delegation, they contact the right NCC, send in an application. This is then sent off to the ITU for approval. When the ITU approves, then we do delegation for this telco for the country. We also operate an AS112 node. Is everyone here familiar with AS112? If not, please raise your hands. All right, I will briefly explain AS112. It's a system set up to basically mop up queries for RFC 1918 reverse zones. So private IP address space, for example, 10.0.0.1. If you're running a network with these addresses, your devices are going to send queries to your resolver to look up the PTR records of devices on your network. And if you've not configured your resolver to answer these queries, then these queries will go all the way up to the root. And because these addresses are not supposed to be routable and no one is supposed to be running zones for these, we end up with all these useless queries at the root zone. So the IANA set up black hole servers, and these are operated out of AS112. So various organizations on the internet run them, and if you happen to leak such a query out, it ends up as one of these nodes instead of going all the way up to the root service.
Do you mind if I interrupt?
Not at all.
Yeah, we also host one of these nodes at TREX, and we get about 200 queries a second, but the coverage for the server is not very large.
Yeah. So we operate an instance at the Amsterdam Internet Exchange. It's a globally routed instance, so we get several queries there, about 3,000 per second. And then we also run all the right NCC internal DNS services, so we manage all our own zones, and all our own users on the network come to us for any DNS related questions, issues that they have. So the right NCC has been involved in DNSSEC for a relatively long time. We were actually the second organization in 2005 to actually sign our zones. The first one was the Swedish registry. And at that time we signed all our zones and published them. At that time we were using Olaf Kolkman's Perl tools to sign and manage our zones. Olaf Kolkman was one of the people involved heavily in the development of the DNSSEC protocol. He also worked at the right NCC at the time, and he wrote a whole set of Perl tools to generate keys, do rollovers, and stuff like that. So we used these for a long time. Once we signed our zones, of course at that time the root zone was not signed. So we published all our trust anchors on our website with PGP signatures so that one could verify that these were indeed the trust anchors of the right NCC zones. We used to roll our ZSKs monthly, once a month, and we had a schedule to roll over our KSKs every 6 months. This whole process was rather manual. When it came time to do rollovers, everyone sort of had their hands up here. Oh no, KSK rollover time. Lots of manual steps were involved. People make mistakes. So we sometimes had errors in this process. But one of the main goals of the right NCC in signing and doing DNSSEC early on was to actually expose all the various problems and issues that people could face, and to learn from the various mistakes, our experiences. So it was okay to make mistakes because we learned from them. So after about 5 years of running this, we decided that the time had come to change things around and improve things. So we redesigned our entire DNSSEC setup. We chose to deploy a commercial product from a company called Secure64. They have a signer product. Basically, it's a black box solution. You provide it your zones, they go in, they get signed, and out come signed zones. This is a software solution. There are no HSMs in the hardware. All the keys are actually kept in memory and on disk. However, they have designed their system to be fairly secure. It's FIPS 140-2 Level 2 certified. They have a secure operating system underneath the signer product, and it uses memory compartmentalization and various other security techniques to actually try and keep the keys out of the hands of the bad people. At the same time, we updated our DNSSEC policy and practice statement. This is available on our website if you'd like to read it. It's pretty much based on the work that was done by done at the IETF by Fredrik Grimren and some people at the Swedish Registry. They've developed DPS, and ours is modeled pretty much along that. At the moment, we have a total of 116 signed zones. So this includes all the reverse zones that we operate, as well as all the forward zones like right.net and associated stuff. Most of them, fortunately, now have signed parents, so we're able to reference the DS record of these into their parents. We still have 10 which are islands of trust, and we're hoping that very soon their parents will be signed as well, so that we no longer have to publish trust anchor files. We're using 1 kilobit ZSKs and 2 kilobit KSKs as we had before. So, as a user, as a customer of the RIPE MCC, you have address space from us, and you have your reverse DNS zones. How do you provision for them? So the usual way to do provisioning is to create a domain object in the RIPE database. Here's an example. If you have the prefix 193.0.14.0/24, if you want reverse DNS, you create a domain object like this. Our provisioning system goes away and turns this into a delegation. And if your zone is signed and you have DS records, then you can actually insert your DS records into the domain object with DS RData. There are detailed instructions on how to do this on the RIPE MCC website in the reverse DNS how to. I would encourage you to look at that if you're interested in this. So we've been looking at the number of secure delegations in our reverse zones since about 2007, and it sort of was growing, but very, very, very slowly. And then there was a sudden jump around about when the root was signed and people started thinking of DNSSEC and started going more and more signed zones. Even then, it's no more than about 400 secure delegations out of several thousand. It's not even 1% of the total number of delegations in the reverse space. So some of our experiences running DNSSEC and doing KSK rollovers actually. These are some of the issues that we've experienced. We've had bugs in software that have actually missed signatures over the DNS key RR set. We've had timing related issues where, for example, the signer software has been too hasty in withdrawing an old outgoing key. And because of caching effects, if you withdraw an old outgoing key too early, then some validators will start to fail. Because they still have the old key cached and they're trying to validate signatures made with that key, and they haven't seen the new keys yet. And the signer is supposed to wait for at least 2 times the TTL of the DNS key before withdrawing, but it's got a bug and it's withdrawn the key. We've had issues where a duplicate key tag led to the signer signing with the wrong key. So it generated a new key for a zone, which happened to have the same key tag. The RFCs actually allowed for this, but the signer was using this key tag as an index, and so it signed with the wrong key. So it looked like it was the right key, but then when you dug deeper, you found out that things had gone wrong. And the signer needs to look up the parent zone to find out if a new DS record has appeared, and it happened to be looking at the wrong parent zone. So all these various things lead to breakage when you do KSK rollovers. And if you push out your zones into production, then people who are validating start to notice these errors. More and more people are actually validating now, so it becomes even more of a problem than it was before. One of the other headaches for us, like I said, we have 116 zones, and they have various different parents. So when we do KSK rollovers, we have to contact the IANA, we have to contact ICANN, we have to go to our domain registrar for rights.net. We have several other different zones from different places, and we have to go to each one of these registries to update the DS records. That's a lot of work. So each time KSK rollovers come up, we basically spend maybe a week just doing this rollover, almost exclusively. So when we started to have these problems, we went for the approach of a walled garden. So around the key rollover event, what we do is we stop publishing our zones. So this means that if you submit updates, they're not visible immediately, but our provisioning system can typically take a few hours to process requests sometimes. So a delay of a few hours is okay. So we actually pause zone publishing, and then we wait and watch, see if things are going okay. Once the KSK rollovers have happened, then we extract all the zones from the signer. We run them through LDNS verify zone. LDNS is a DNS library written by Element Labs, and it comes with various tools to check zones. We start instances of resolvers, load them with trust anchors, and check to see if the zones validate. We check to see if the DS records that have come out of the signer actually match the keys that the signer is signing with. And then what we do is we typically would update the DS records of one or two zones, zones that have less priority, that if there was any breakage would not be a big disaster. Then we wait and watch. And if we're satisfied, then we go and do the rest. So we shouldn't have to do this, but the reality is that we do. And that's because our experience shows that KSK rollovers, despite all the things you do to make it smooth, can be risky. This is a question that people everywhere are asking. Should you roll over or not? If you've been following the DNS news, you'll notice that, for example, the root zone key is not going to be rolled for at least 3 to 5 years. That's the statement made by the operations. And my guess is that it may actually be 5 years before they decide to roll. Some other registries, Dominant, I think, announced that they were not going to roll their keys that often. So people are actually starting to move to a situation where they're not rolling so frequently. But rollovers are also necessary, because if you don't ever roll over, when it actually comes time to do one, you may have forgotten how it works. You might have new staff in your organization. They've never done DNSSEC KSK rollovers before. Oh, how do I do this? Things break. You have to train them. So you have to practice these things, otherwise you start to forget them. And you need to do some of these things to catch bugs in software. I mean, of course, you can do all this in a lab, but eventually you've got to do this live at some point, because there are some things that you just cannot catch in labs. So how frequent? Well, people are adopting different attitudes. Some are doing it every 3-5 years. Some are doing it, well, when there's compromise. We're looking at perhaps doing yearly rollovers. We haven't decided yet, but it's something that we're talking about now. And we need to discuss with the community and possibly move to 1-year rollovers. The other interesting question is, why should you sign your reverse DNS zones? I mean, even forward zones. A lot of people have, how many people here have signed their forward DNS zones? Not that many, a handful. A lot of you aren't signing your forward zones. Why would you even sign your reverse zones for that matter then? Like I explained earlier, showing the graph, the number of secure delegations in the reverse tree is so tiny as to be negligible. Well, here's one good reason. Practice. You don't want to be practicing with your main zones, your forward zones, in case you break them. But reverse zones, not many applications rely on reverse DNS. Yes, mail does. But
remote access relies on.
Yeah, some remote access as well. But you could get away with breakage more easily with reverse zones and forward zones. I'm not saying I'm not saying that they're completely useless, but they don't.
There's a counter-argument though.
Yeah.
The problem with that is that if it's not used, it might take weeks before you notice that it has broken.
That's also true.
Whereas if it's your website, main, public front page, then you'll notice it pretty quickly.
Yes. No, that's completely true as well. But if you're going to start with your reverse. It's a good place to start. The other interesting thing I've been hearing about recently is some people are making noises about maybe putting secure routing information in reverse DNS. You own a prefix, you likely control the reverse DNS for this. You might want to put some information in the reverse DNS tree about your routing, and then sign it so that somebody can look this information up, validate, and then use that to make decisions in their routers. So I don't have more details, but watch this space. Keep your ears to the ground. You might hear things about this in the near future. And this will become an interesting use case for signing the reverse DNS tree. And I would like to say Kitos, Ektasan Huatala. Any questions? I'm going to be here this evening as well, so you can ask later. Yes?
Have you thought about DNS as one, like a thing, this rightness stats?
How do you mean?
You have this rightness where you can get stars if you have working IPv6 and so on. So have you thought about putting DNSSEC there?
We haven't, but that's a very good idea. I'll take it away to our right staff team and see what we can do with it. Thanks. No? Well, thank you everyone for listening.